Hello, everyone. I'm Charlie Schick, VP of Marketing for Quartic AI. Quartic AI provides a powerful, open, and modular operational AI platform with industry-specific AI applications that accelerate time to value for our customers' Industry 4.0 initiatives. Our focus in today's webinar is how customers can accelerate their success with advanced batch analytics. Our speakers today are Dennis Brandl, Chief Consultant at BR&L Consulting, Michael Bartlett, Sales Director, and Brian Pope, Solutions Engineer, both from Quartic. Today, we'll start with Dennis talking about where batch analytics has come from and how customers should be moving forward. And next, Michael will describe the current state of operational analytics and what a highly capable AI-driven batch analytics platform should look like. To close, Brian will show a demo of Quartic's advanced batch analytics capabilities. We'll wrap things up with a question and answer session, so feel free to post any questions in the chat during the webinar itself, or you can post them at the end during the question and answer session. So with that, I would like to turn it over to Dennis.
Okay, thank you. And Charlie, if you could stop sharing, and I will share my screen. Okay, so thank you everyone for attending and for taking your time here to go through this. What I'd like to talk about a little bit is some of the issues that occur when you're looking at using batch and batch systems and how you can optimize those. Just give you a brief rundown. I've been a member of the ISA 88 committee actually since 1990. I didn't get started on it until a couple years after it got started, but also been involved in several other ISA committees as well as MESA work and others. So I felt that it was appropriate to talk about some of this given some of the age that exists right now in ISA 88 and how prevalent it actually has been used. So just to give you some context of what we want to go through here today, one of these is talk about, well, ISA 88, it's great. Doesn't cover everything. I mean, it wasn't even intended to, but it really did give us a great leap forward in production performance improvements in batch systems particularly. So people got percentage improvements in throughput, reductions in batch times that were significant, major improvements in production quality, reductions in off-quality products and all these sort of things. It was great, but to get that next level of optimization and performance improvements, we really have to look a little bit beyond that. And then there are three real major areas that we're looking at where people were stepping beyond what we had originally defined in ISA 88 and what they now are using and other things. I want to cover each of those things. One is the fact that ISA 88 dealt with batch, but in actual fact in operations, we need more than that. Missing material information and missing design space information. I'll just talk briefly about each of those. First, let's talk about the elephant in the room. Okay, ISA 88. ISA 88 is a de facto standard for controlling batch systems. Most vendors today, most control vendors have some sort of batch execution engine that follows this model. But you have to remember, this was released in 1994. Most of the original members are now in their 60s, 70s, or retired or passed on. This was way even before Windows 95. So you can imagine the environment we were trying to define this thing in. It's been quite a few years here. It was really designed for manual or automated systems, but we really limited the complexity of what we said you needed to do in a batch context and to do batch optimization to what you could do manually. Back then, Windows 95, Windows PCs, et cetera, weren't as reliable. People didn't want to trust them. So we had to make a lot of choices as we developed that. I couldn't even raise the issue of having an intelligent agent that was actually executing a recipe in lieu of an operator doing it. Just because we didn't have enough software people on the project to talk about it, let alone to talk about advanced analytics. So the issue is that 88 was really just designed primarily for manual control of equipment or automated control of equipment. Didn't matter whether it was a PLC or DCS turning something on or off, or a person doing it. But it worked. It worked really well. People found great improvements for it. That's really nice. But now we know a lot more. Now we have a lot more capabilities. Now we essentially can look at things and say, okay, yes, these things can be and should be automated because they will reduce variability, they'll increase productivity. So fortunately, I was able to announce here that we're starting some new work in 2022 for a major update and refresh of this. So I'm hoping that we will be able to take some of the things that I'm talking about here and moving those forwards into the standard so we can get some better optimization on our batch systems that we have out there. The first part is the missing batch context. If you take a look at systems that are used today in production environments, there can be anywhere from 50 plus, 60 plus systems, and I'm using the word systems loosely, ranging from power systems, building management, security, environmental systems, material management systems, laboratory information management systems, computerized maintenance management systems, as well as dozens and dozens of spreadsheets, all of those involved in the manufacturing process. And particularly in the life science industries, many of these things have to show up in what's called the batch record, what actually went on in there. Now, ISA 88 Part 4, that provides a model for actually recording that information and storing that information, but it doesn't really talk very much about how you're supposed to go collect that. And part of this is that these systems provide information, but they don't necessarily have the context that can be used for analysis, particularly if you're running multiple batches at the same time. You say, oh, yes, we had a power glitch on this line, or we had an equipment failure on this line, but you may not know at what state the process was actually in. So these things happen, and lots of strange things will happen when you're running a batch. One example that we saw was the batches were losing batch data, okay? Not necessarily from the attached system, but from some of the non-batch systems that you're trying to pick up and get the context on. And people were going like, I don't know what's going on. Someone happened to notice that at random times, the routers were rebooting. And then somebody else noticed that once the operators were filling all their water bottles from multiple water dispensers at the same time and discovered that all the routers were on the same power circuit, it dropped the voltage long enough to reset the routers, not enough to reset the alarm. That's the sort of problem you can't find unless you know context, unless you know what's actually going on. And the context there was, yes, we're running the batch, but the batch was paused because the operators were off doing something else. Another case, the system was running, and it turns out the security department was running port scans that overloaded systems, even caused memory wipes of PLCs. We knew what the security was going on, but you didn't really at that point in time have any context to say, oh, why did we lose the data? Oh, we lost the data because there was a security scan, because we never tied the security systems into the batch logs to see exactly what's going on. So without that context, any analysis is really, really hard to do. Now, those two mistakes I just talked about, they're dumb mistakes. We don't make those kind of mistakes anymore. We're often making brand new ones instead. But the whole idea here is that you have to provide the information that's not coming into the batch system, that's coming from all of these secondary systems out there, and provide the context for that information. Otherwise, it's just data. Another issue that came out many times in looking at it is to try to do optimization around material. Well, in 88, you don't really talk about material. It does have some things that you can do, process inputs and process outputs, but really what you're doing is controlling equipment. You're opening a valve and you're hoping that the right material is in the pipe. And then you're checking to make sure that what went in it. Vendors have gone off and they've developed all their extensions to handle this. So you can start to identify material in the batch systems. Now, why is this important? Because it's important for tracking. There was one customer, they had the client that we were using, where it was in biotech and they were losing batches, again, apparently at random. Well, after a lot of investigation, it turns out that the Teflon O-ring that they had used on one of the batch reactors had changed the formula. And after the first batch was used, there was a chemical that leached into the fermentation tank and killed the cells. So that was causing the batches to go bad. Now, would you normally catch this? You would catch it only if you were completely tracking all the material information, everything that went into the batch and everything that came out of the batch. So this better understanding of specific material lots used and their properties can help you in your optimization and preventing problems, and also help you look at batches and determine, yes, for these materials, I'm on a golden path. I'm making sure that the transactions and the process is progressing as it's supposed to, and for others, it's not. So sometimes knowing what's in the batch or knowing what's come out of the batch is very important. That's right now missing, but it's something that you need for all of your analysis. And then the other piece of it that's really missing is the design space itself. Now, many times we do tech transfers, and that tech transfer is to pass information from one department into another department or from one site to another site. But the issue is that not everything is often part of that technology transfer. We don't necessarily go everywhere from R&D into production and then into outsourcing itself. Oftentimes what we do is we will ship engineers around the world to try and talk things through. Now, with the latest with COVID, we're not shipping engineers. We're instead sitting on Zooms and team meetings for days and days, apparently, trying to do a technology transfer, which is probably no more advanced than what we used to do sitting around a fireplace telling stories. Now we're doing it electronically, but the issue is we're still manually trying to transfer this information, the design space. What are your error bars for the optimal process trajectory? What's the golden path? When you say 45, is it 45 plus or minus 0.1? Is it 45.0 plus or minus 0.1, et cetera? We have the technologies to do that today, but they're not really being applied effectively. And you do multiple technology transfers for each product. You'll do it for your primaries, your secondaries, you'll do it for your packaging, you'll do it many times, you'll do it as you scale up for different releases and as you outsource it. So we have an information loss each time. Right now, this is probably one of the biggest things that's slowing down optimization of batch processes, is you don't know exactly what your degrees of freedom are and how you want to do that. So this is just a brief overview and a brief discussion of what it is we're actually looking at, and they're going to talk about here briefly. So just to reiterate a little bit about what all these things are. We look beyond ISA 88 for complementary standards. We need to determine how the batch context to data is added from other systems that don't have that context. So you know what phase you're in, so you know what stage you're in, or your operation or your unit procedures. We want to track all the materials and actually make those part of the records that we need. And we need to maintain and use that design space information to optimize performance without really impacting the quality we have. So hopefully the rest of this discussion we have here, you'll see some of the solutions that people have come up in making these things work. So thank you very much for this. And then we'll have some questions at the end as well. So
thank you, Dennis.
Here. Yes.
So the current state of operational analytics technology. Currently, there are many point solutions being utilized in operational analytics. There are typically multiple systems deployed, all serving their own specific purpose. In an ideal world, they consume data from a historian with contextualized data. At a minimum, visual analytical tools overlay time series data from batch to batch and visually support the user in the search for data that is in or out of spec. While that's helpful when you know what you're looking for and more capable than time-based visual trending, a user cannot possibly process all those visual trends overlaid on top of one another and easily find correlation or causation in the outliers. To add, the user would have to have separate applications for critical alarms, SPC, offline models, and multivariate analysis, or QBD, CPV, and predictive analytics. So OT teams often deploy those advanced analytics applications on-prem because their legacy technology is often only supported there. The support for how they integrate the data sources is varied. Those that have the ability to map the context capabilities of the site historian are the most user-friendly, but many still only map to the streaming data via an SDK. In some cases, applications might actually require a connection directly to shop floor systems to grab that data. In many cases, these tools are extended beyond their original capabilities, such as making an SPC application do CPV by connecting to a source of data. So while machine learning is some basis in SPC at its core, the ability to make adjustments to make the analysis better is difficult, if not impossible, because the systems are only based on these statistical methods. Remember the analogy from the modern operational data platform webinar we just did a few weeks ago. You cannot turn a turboprop into a jet by adding new engines. This added complexity becomes a burden to deploy and maintain. The lack of interoperability also means that each of these systems requires separate integration of the data sources, which then requires separate time, effort, and cost to maintain. If utilized in a GXP environment, each of these systems would require compliance and rigorous change control. Each of these point solutions required separate licensing. And then from offline to online, separate applications and workflows make them difficult to maintain. So even if you forget that all these applications are individual, you know how much work it takes to do deviation investigations. But in these point solutions, since you aren't able to put the investigation in the form of a model to then use in operations, if you don't make it predictive, at the very least, by putting it into a model, it would be valuable to have the system perform the investigation on your behalf. So Golden Batch. Golden Batch is something that everybody on this call probably knows pretty well about. The concept is for the system to recreate the exact conditions that previously produced the ideal batch. This requires recording process variables over time and analyzing the resulting data to determine the critical attributes. If the recipe is followed perfectly and the process stays on course, the resulting time-based profile is referred to as the golden batch. And the expectation is that once such a golden batch has been made, the sweet spot can then be replicated. Well, the fact is that achieving an ideal outcome, such as yield or quality, is a lot more complicated than simply following the same recipe. The dynamic relationship in the process, along with the variability of materials, for instance, you found a different media supplier, or like as Dennis pointed out, the material in the O-ring changed, that variability in a range of qualifications and equipment often mean that multivariate relationships must be constantly understood in the existing operating context. This is different from a fixed understanding of the golden batch, because in reality, multiple control parameters must be acted upon. The system cannot always recreate the exact conditions that previously produced the ideal batch. But fortunately, there are techniques available that allow us to take advantage of the degrees of freedom provided by the design space and the control space defined during the product and process development, a recommendation that Dennis just put forth. So in Pharma 4.0, we want to focus now on how to best achieve golden outcomes, which means using machine learning to achieve the best possible outcome when there's variability, or in an ideal sense, optimization of the process to achieve higher than design outcomes. Alternatively, in the worst case scenario, if a batch deviates beyond acceptable critical parameters and is predicted to be unrecoverable, operations at least know sooner and can stop the process before more time is wasted. So even a gain in hours has value, and the circumstance can also help train the models to track and mitigate those future problems. As Dennis mentioned, another benefit is characterization, meaning that if you know what happened to the materials before they entered the batch, or know what materials were used in the previous batch, that can all be used to control or even predict the outcome. So an ML application can be helpful through the entire product lifecycle. To echo the point Dennis made, if you can explore all ranges of the acceptable design space, starting in the DOE phase and into process development, and learn that an ideal outcome can be achieved outside of the specifications set forth in molecule design, the utilization of that data to build a model that charts a course to ideal quality and yield can be extremely beneficial when adapting to variability during all phases of manufacturing. If the batch had a deviation and past experience proved that the product still met the requirements, you can leverage evidence-based batch release. So to change the culture towards golden outcomes, you should start leveraging ML in process development. So how do we get there? How do we use that technology? Well, I want to just mention the modern data platform that we discussed in the previous webinar. So this OIT data ops ready system is the starting point. So in a foundational sense, now that the platform, what can the platform do now to drive towards golden outcomes? Now, keep in mind that all the following capabilities that I'm going to talk about are available in the same platform from Quartic.ai. At its foundation, similar to the OIT system, the analytics have to run where the customer needs them to. Typically, when used as critical support for operations, they'll have to run inside the four walls. However, systems can now run very reliably and leverage fundamentally limitless scale in the cloud. Or one can choose to create a hybrid architecture. The technology must be able to support that flexibility. It must also support data ops, readily being able to consume contextualized data. The technology must be easy to configure. Workflow-driven configuration is key to making the technology easy to consume by subject matter experts. Using the same tools for offline and online use cases is immensely valuable for turning investigations into features and soft sensors. All of the above should be the building blocks of a true digital optimization strategy. So the analogy is that NASA or its peers can shoot any type of rocket into space with a good launch pad. So after that foundation is set, you need simple tools that the users can interact with, like batch-to-batch comparisons, deeper dives when you find anomalous behavior, and critical alarms to announce and record issues. So at this point, maybe you can launch the Saturn rocket. So at the next level, now we have multivariate analysis and using basic SPC tools to identify when a variable is tracking in or out of spec. Knowing that the investigation into anomalous behavior takes time, the next level capability is building an ML model to track and do your investigations for you. As I mentioned before, it takes time and effort to do deviation investigations, but turning the work into an operationalized model saves considerable time. Even if you don't make it predictive, this can move you towards real-time release. Now take that to the next level by using ML to predict when the trajectory of a parameter might be moving outside the safe operating limits, which would allow ample time to take corrective action and keep the batch running on course. So at this point, you have more rocket boosters and a space shuttle built using the same platform, but you still haven't achieved the ideal. The true promise of 4.0 is autonomous manufacturing. But again, that could require a culture change. So at the very least, the technology needs to support building blocks to get you there, using an optimizer that drives towards golden outcomes like better yield, higher quality, and faster batch release. Your organization may not be ready to give way to the machines making decisions just yet, but using this technology, the foundation will be in place, and the journey to build that complete system with different levels of sophistication will be in the same set of tools. Soon that rocket will be taking off and landing on its own, ready to be used again and again. Now on to Brian for a demo.
Great, thanks, Mike. So like Mike said, I want to demonstrate some of the tools available within the Quartic platform and specifically our batch analytics application. And to do so, I'm going to use a penicillin fermentation process as an example. This is an adaptation from an actual customer use case that we helped solve. And in this process, we've been having issues with inconsistent yield. So our average yield is right around this 88 grams per liter, but we can see, we have a bunch of batches that are 10% lower, some that are 10% higher. So we know that we can achieve this 10% higher output. So that's what we want to try to minimize these lower yield batches, move it up towards the higher end, and improve the overall consistency. So to address this, we'll go through a workflow similar to what Mike kind of outlined with going to those next level analytics, where first we need to identify where that variability is coming from. And this is going to use multivariate data analysis driven by machine learning in an offline mode. So we're looking at historical batch data to identify this variability. Once we have an understanding of that, as well as the underlying factors that are leading to that variability, we can build and deploy machine learning models to compare real-time process variables, so variables coming in for a current batch run, against a target profile. And that target profile will be generated from those high yield batches we have. We can essentially create a composite golden batch profile that's more flexible because it's being driven by machine learning models. So it's not purely recipe driven. Since it's driven by machine learning, it can take into account changing environmental conditions, changing raw material properties, differences in equipment performance between different reactors, et cetera. So it becomes a more agile and proactive approach to our batch monitoring. Then finally, we'll go that one step further into predictive, where we can predict both our yield profile and also those underlying parameters and compare those predictions to that golden batch profile, which will give us even more time to take preventative action, leading to that increased yield and better consistency. That was just a quick run through of what I'll be showing through the demo. Now I'll actually hop over into the platform itself. And just to quickly show you, Mike mentioned, the foundation of this is that modern data infrastructure. So we already have that in place. That work has already been done. If you want more details on how to actually set this up, you can view our previous webinar on this topic. But just to show you, this is already in place for my reactor. I can choose my date range to pull in my batches. And then based on those batch runs, I have all my data items available to me. So I can select these different batches, pull in, say, my dissolved oxygen, add in the temperature trend. So now all these variables are already assigned to my batches, the equipment that I'm using, and now I can analyze these, overlay them on top. And we have also kind of the SAD, the phases built into this. So we have our actual fermentation phase, harvest, CIP, standby. So all this context is already built in. And now that that work has been done, it makes it much easier to move on to the next step of doing the advanced batch analytics. So if I open up my batch analytics application now, we can see that same context is here. So I'm a penicillin fermentation. I can choose which process unit I have, search through my time range to find the batches I want to look at. And now this is trying to figure out where that variability in my yield is coming from. So if I don't have much of a starting point, I can just say select all. So this is going to pull in all those different process variables associated with these batches. And again, I'm going to look at yield. So I'll size all these dots by yield. So this is performing dimension reduction, taking these 20 or so variables, reducing it just into an XY scatter plot with 2 different dimensions. And now I can say, all right, I have some batches with smaller yield over here. I have some with higher yield over on this right-hand side. So I can select those different groups. And now I want to understand which of these variables at the top are contributing to this variation in yield. So if I hit analyze, there's a few different things going on here. So the primary one I want to look at is I have this ranked list of variables for how much they're influencing this difference in yield. And the purpose of this is I don't want to have to focus my attention on all 20 of these variables. I want just the key ones that are having the most impact. So I can optimize those first. And then maybe once that's running well, if I still have some differences, then I can move on to kind of lower ranked ones. So I can reduce this list to I'll just choose the top 4 from this list. So I'll go into my bioreactor pH, CO2, DO, and temperature. Now, what you'll notice when I do this is there's not as good of separation as I had before between the higher yield and the lower yield groups in the scatter plot. And the reason for this is this ML ranking is just one tool available to this application to identify parameters. I also have other tools such as visual trends, where I can look at the differences in profiles between my lower yield batches in orange and my higher yield batches in blue. I have statistics summary tables. So using some of these other tools, I can also potentially identify some other variables. So for example, if I look at agitation, the average values of these seem to be pretty similar, but you can see the lower yield batches, they aren't controlled as tightly in terms of agitation. And thinking about this, if the agitation is too high, we can be introducing foaming, shear stress. If it's too low, we can have inefficient nutrient transfer. So having a tighter control could be a pretty important contributing variable. And I can see that difference in ranges in blue for the higher yield versus the lower yield group. And this also shows up in my standard deviation as well. So this is where some of your process knowledge and expertise can come into play. This application isn't meant to replace process knowledge or replace process engineers, but to give you a tool set that allows you to give you additional insights and tools to support the existing knowledge you have. So based off of this analysis, I'll add agitation in here just to see. And this creates really good separation between these 2 batch groups. And actually, I'll add this batch in here too, because it's closely associated. So now that I have this, I have an understanding of my higher yield versus my lower yield, and these are the 5 parameters that are contributing the most to this variation. So now I can save and deploy this as a machine learning model. Let's call it penicillin yield. And I want to use this group B, which is my higher yield batches. So I'll hit confirm and monitor. And this will now deploy as a machine learning model to monitor this yield profile in real time. So it's taking those 4 higher yield batches, creating a composite score for those, and now I can compare other batches against that running in real time. So for example, if I choose this batch 80 at the bottom, we can see there's a lot of separation between my reference group and this tiny little green dot here. So if I want to understand why this is happening, I can hit analyze. And this is going to do a very similar analysis to what was being done on the previous page, right? I can see those visual trends for variation in my different process parameters. I have my dimension reduction being done. The one key thing here, now that we're doing this in real time, we also have this probability score. So this is the probability that the yield of this current batch run is going to come out within the acceptable range based on this golden batch composite score from these 4 reference batches. So 17%, that's pretty low. Clearly something's going on here. So this is where I might flag this. So I can do this visually here, but I could also send out an email notification saying, hey, it looks like we have a high batch variance going on. I could integrate with a QMS system to automatically kick off some sort of workflow. But the nice thing here is now we're doing this in real time versus waiting kind of offline mode after the batch is already being done. Right. But what would be even better is if I can take a more proactive approach and move this from real time to predictive. So that's what this next tab for the trajectory is doing, is we're going into predictive, where I'm creating a predictive yield profile using a machine learning model. So all these green dots are what's happened so far in my batch run. The red line is now, and then everything off to the right in orange is predictive for the remainder of my batch. So these are my predictive yield scores. And then for those 5 variables, I also have my corresponding process parameter profiles predicted out as well. The upper and lower, the lighter orange band. So this is the upper and lower limits of those composite batches. So out of those 4 batches I chose, these are the upper and lower limits for, say, my yield, and also for each one of these process parameters for those batches. So it gives me not only what my model is predicting, but kind of this acceptable range that I think I should stay within in order to get my optimal yield. And you can actually see that my yield right now is trending right around this 96, which was on the higher end of that batch performance from that bar chart I showed early on. So the idea here is if we started one of these predictions starts falling outside of this expected profile for high yield, that's where we would set up a notification, start taking corrective action, look at which trends at the bottom here are also trending out of spec, so I know which ones I should be taking a look at and go deeper into control for. One other thing I want to point out here is all of these models, they're running within that same modern data platform. So for example, this temperature, if I use this as an example, if I go back into my platform, this model running right in here. So I can actually come and see the model that's running. I can turn it on and off. I can view the model itself, view logs for it. Everything is fully integrated here between the application and the platform. I can also come in, this temperature prediction is also being saved as a soft tag. So I can come in, overlay my real-time vessel temperature along with my predictive. So this tag, and I can also overlay my actual batch base as well. So this prediction becomes another tag, another data point within my platform that then I can use for ad hoc trending, like I'm showing here in my batch analytics application, in dashboarding, and it can also be used to feed into other machine learning models. So that final step, the optimal idea behind AI is getting towards AI-driven control or AI-driven optimization, where I can actually make set point recommendations for my process based on these machine learning models. So if my current yield profile is trending off of that optimal, off of that composite golden batch, well, what changes do I need to make to get back to that golden batch? And that's what this process optimization module can do. So this is something that's provided by Quartic, but I'm going to leave this as a bit of a teaser or a cliffhanger. We'll go more in depth in this particular application in a future webinar. But just know that that kind of Pharma 4.0, that next step is available within the Quartic platform as well. So hopefully this gives you a quick idea of kind of the capabilities of our batch analytics application, starting with that offline analysis mode, moving to online real-time, and then into predictive trajectories for, in this case, yield, but it could be for any other quality metric as well. So with that, I'd like to turn it back over to Charlie to close us out.
Wonderful. Thank you, everyone. Let's go into a Q&A here. We've already have some questions here. So I got one for you, Brian. This is from Mohammed. You said something about good separation between low and yield batches, and there was a small and big circle next to each other. And so he's just wanted to know a little more clarification. Are you able to clarify that a bit? You were looking for more of the contributed features that were talking about high and low yield, and there was a small dot next to some of the bigger dots. So
Yeah, so it's looking at not just the yields, but also the groupings of the batches as well. So because even if we perfectly control it, there could still be some that, given conditions, there could still be some that have slightly lower yields. So it's really looking at the groupings and kind of overall higher. I could go in and also just not select that one. But then we're getting into just fewer numbers of batches. So that it's kind of something that you can play around with a little bit. But that was just the choice I made kind of walking through the demo. But yeah, the one that he was talking about was this one over here. I think it was this one. Yeah. So I could also just as easily choose these three and see what impact that has on the analysis versus kind of doing the larger grouping.
okay. All right. Dennis, I got one for you, right? So you're talking about ISA 88. How much do you see people using it? And to add to that, you were talking about context as well, and how does it affect how people use ISA 88?
Yeah, at this point in time, a lot of people are using ISA 88 primarily because their vendors are using it. So if you're using RS batch or in batch or semantic batch or any of those things, you're using it. A lot of those issues or the concepts that are in there has also gone into the MES systems that are out there. So while people may not be aware of the ISA and IEC standards that are out there, they actually end up using those. The big issue of context right now, it's a lot of integration that generally has to occur. People have been moving to data historians that provide some of that context, and I think you saw some of that in a little bit of the presentation and a little bit of the issues there, so that when you're collecting time-based data, you can at least provide some events that show up inside something. But the issue there is that when you've got multiple batches running simultaneously, you may know from a time sense when something happened and how that might relate to it, but you may not know for exactly which equipment is out there because you have shared equipment, things that move around between batches. We actually have a lot of mobile equipment that moves around. So it is still a problem to be solved, and people are working on individual solutions to that right now. But the thing is, you just got to preserve it and then look for using an analysis techniques, look for the correlations, just as was shown here.
And how do you see AI affecting how 88 evolves?
I think the issue there is the fact that, again, if we want to find patterns, as humans, we're pretty good at finding patterns, but really we only operate in a 2 to maybe a 3-dimensional space. The issue that shows up is AI allows us to operate in a multi-dimensional space, not necessarily to try and have to find the right dimensions for the correlations that are out there. And each dimension can be another piece of equipment or set of equipment. So I see AI as really being a great assistant to help us find correlations that otherwise it's going to be very difficult for us to recognize.
I got some other questions here. And this is probably Brian or Mike. Are you able to use the software for continuous processes to bring the processes back into control and to target? Yeah, so Brian and Mike, you can talk a bit about that.
Yeah, sure. So absolutely. And we have done this and are currently doing it with customers. So there's one example use case that we're doing it on a continuous reactor for small molecule that is using our process optimization module. So it's using a combination of kind of what I showed in terms of identifying the key variables, and that's going into a machine learning model to do real-time closed loop control within the continuous reactor. So yes, we can certainly do that.
And then we have another one here. Can the batch context be drilled into individual phases of a batch? And is there a requirement to provide contextualization around it? So, agitation starts from X to Y, PHDO control start from A to B. So, yeah, so requirements and contextualization.
Yes, so we can include the individual phases as well. So kind of the example, when I was showing the overlay trends at the very beginning, you can actually see those individual phases. So that can be fed into the batch analytics application as well. So I was doing it just from the kind of overall batch level, but if you wanted to drill down into individual phases and have that built in, then that's entirely possible.
I mean,
So
they just become features, right, of the model.
exactly, yeah. So typically we would prefer to have that predefined, but the other thing with that application is very configurable. So if you wanted it to be more, instead of searching based on a phase, if you want to be able to do it based on a time or something that context wasn't there, but you want to be able to kind of do that ad hoc, that could be built in as well if that's needed.
And I have one other question here that I don't know how well we can answer, but like, what are the AI methods and algorithms that can be deployed? So that might be, we can talk a bit about that.
Yeah, so that's pretty flexible. So I'll say within the application itself, like one of the main ones for doing the like the variable identification and the ranking there, that's using hypothesis testing, using machine learning. There's other methods that are built into the application itself, but if you have specific ones that you want to use, the entire thing is customizable. So we have the off-the-shelf product, but we can tailor that to your needs, or if you want to write it yourself, it's all exposed in the front end via an API. So you can really write any type of model you want using, say, Python or something like that, plug that into the application and have that being running. So we have our own kind of internal machine learning algorithms and methods running, but if you want to tweak or adjust that, or you want us to help you with that, that's all possible.
All right. Any other questions? Okay, so I think that's it for our question and answer session. I want to thank everyone for your participation today in the webinar, and special thanks to our speakers. We'll be sending the link to any materials and recording in a subsequent email. And if you have any batch analytics use cases that you want to discuss with us, you can contact us and we can go deeper into the platform. So for all of you, have a good rest of your day and thank you.